Wonderful. Well, thank you, Holly. I appreciate it. And I'd like to start off by welcoming everybody who's here today for our session called Energy Intelligence. This is part one of a duology or a two-part series to where this one is beginning looking or focusing on air conditioning. And specifically, the task presented for me was to look at various tasks that can be performed on site by apartment maintenance technicians to ensure energy efficiency of air conditioning equipment. Now, the second part of this section will be at the end of August, and I will be joined by David Jolly, where we're going to look at much the same content focus. However, we're going to be looking at heating systems, and there we're going to be looking at both heating for garden-style apartments and high-rise, dealing with hydronic systems and the various applications that we can expand this concept of ensuring that we have good practices for our on-site maintenance staff regarding heating and air conditioning systems. Now, just by way of a little bit of background for myself, my name is, as Holly mentioned, Paul Rhodes. I'm the National Safety and Maintenance Instructor for the National Apartment Association Education Institute, and I've been working in the multifamily industry for the past 23 years. I started out on site working around the Atlanta area on all different property types, everything from a small, being the only maintenance technician, maintenance supervisor on a small 125-unit community, all the way up to managing or running the day-to-day operations of the maintenance staff for a 978-unit apartment community here in Alpharetta, Georgia. As far as property types, I've worked on garden-style apartments to mid-rise apartment communities. And what we're going to be focusing on today is exactly what I had mentioned before, where we're looking specifically towards energy conservation for apartments. And really the purpose for what we're looking at came from this study that I found a couple of years ago that was conducted by a California utility of residential heating and air conditioning equipment, that it showed that 68% of that equipment was improperly charged, meaning it didn't have the correct amount of refrigerant in it. And not only that, over 2/3, 70% have the incorrect amount of airflow going through the system. Well, both of these point to problematic maintenance. Now, in the apartment industry, we do have a little bit of a different focus than residential construction or residential maintenance at large, to where what we're looking at in the scope of this particular session is just looking at talking about maintenance. We're not going to be talking about building new construction or the systems or things that we need to do during new construction. We're looking at already existing equipment. We're looking at already existing properties that are built currently. In addition, I'm not in the place to provide product recommendations as far as being able to tell you one brand name over another or one type of system over another. And that's really beyond the scope of what we're looking at. Here, we're looking specifically at maintenance, which we're defining in this case as we ensure the equipment operates as it's designed. We fix broken stuff. And we do items or do things to prevent catastrophic failure in the future. Now, with that in mind, I would like to direct all of the attendees, everybody here, to your chat window on the right-hand side or wherever your particular control box seems to be on the computer screen. In that chat box, we're going to be able to take your questions at the very end, and I would like to answer any specific information that I can provide or go into more detail than what I covered during the presentation. So as we go through, if you do have questions, please feel free to type a question into that chat box and send it to the particular to line that says send question to staff. and I will be more than happy, Holly and I will be more than happy to provide any extra information that I can provide to you. Now, we are going to be looking at specifically focusing on energy efficiency. And we have to make sure that we're all in agreement about what that means. You see, most of maintenance, most of the repairs that apartment maintenance technicians do on site or perform on site is just surrounding that whole does it work question. In other words, the resident calls in a service request and the air conditioner is broken. It's not providing comfort. It's not cooling the apartment. Well, the fact that it's broken, that is a related but a separate topic than does it operate efficiently. You know, just meeting the customer's needs, what the customer demands, is not always the exact same as making it operate efficiently. And we're looking today specifically at efficient operation. So what we have is a situation that the Green Mechanical Council defines the fact that air conditioning systems take up 40 to 60% amount of energy use across the country. As a matter of fact, back in the late 80s when the National Energy Conservation Act went into effect, heating and air conditioning as well as lighting were identified as two of the largest areas where energy is consumed. Well, lighting, as you've noticed in recent years, we've gone away from incandescent bulbs to where now we're going to fluorescent bulbs and even into LED, light-emitting diode technology. Air conditioning systems are on the same path towards energy efficiency. And new equipment that we end up getting, it by regulation and by requirement is going to be more efficient. But you know, we have to think about efficiency for our existing equipment as well. By not thinking of efficiency for our existing equipment, our equipment does have a shorter life. Not only that, it takes longer to meet that resident demand for comfort, and it results in higher energy bills, regardless of who's paying that power bill. You know, in some cases, our properties or our communities, the resident is completely responsible for the in-unit energy cost. Other places, that in-unit energy cost is baked into as a part of the lease rate or the monthly rate that our resident pays. So in both of those cases, efficiency is a good way for apartment maintenance technicians to look at performing repairs. And where they start is really inside of our apartments, where everything we're going to talk about today can go for both inside the resident space as well as our common areas. And there we begin with the number one need of air conditioning equipment. You know, we start out or begin by looking at what exactly does an air conditioner do? And a lot of people will answer that question by an air conditioner makes things cold. It makes things cool. Well, that ends up being a end result. But the reality is that all an air conditioner does is it takes heat from someplace that we don't want it and moves it someplace that we don't care that it goes. You know, we absorb heat. We're not making cold. We're taking heat away from inside our apartment and moving that heat to outside our apartment. Now, the reason why that's a good place to start when we're discussing efficiency is because in order for us to do that, we have got to have and recognize what it is that we're using to remove heat with, and that is air. We are using air from inside the apartment to move heat. We pull air out of our apartment. We run that air through a filter to remove unwanted contaminants. And then that air is forced to go across a coil where that coil contains refrigerant, a substance that substance job is to absorb heat. Now, as a byproduct of absorbing heat out of the air also gives up moisture to that coil, and that moisture is carried away. So our system, not only is it filtering, not only is it circulating air, but it's also removing moisture, decreasing the humidity in the air, and making that air more comfortable for our residents. But you know, we don't have to just have air inside our apartment. We also have to make sure that we've got air moving outside of our apartment through what is commonly referred to as a condensing unit or our outdoor unit. What this points to is the fact that we've got to start any discussion on efficiency by looking at air and being aware that we have to have airflow everywhere in our system. Now, since we're starting inside the apartment, airflow, we begin by looking at what, for maintenance technicians, should be a very, very common task. And that common task is replacing a filter. So the question I've got for you is, which of these two filters should be replaced? We've got two very standard filters that are used throughout the apartment industry, and the answer is actually neither one of them, at least maybe not yet. You see, even that filter in the back that is starting to show signs of being clogged, it, generally speaking, is not ready to be replaced. As a matter of fact, if we look a little bit further discussing this topic of filters, which of these two filters is actually doing a better job? Which of these is performing its function better than the other? I mean, we've got a 50-50 shot out of looking at the particular operation of these designs. Of course, the filter you see on the right is a very brand new, clean filter, spun fiberglass. The filter that you have on the left is a filter that's been removed from a PTAC unit, a small unitary hermetic system that is installed. And the question, if we're to answer that question, which one is doing a better job? Actually, the filter on the left is doing a better job. Because the job of a filter is to remove unwanted contaminants. It's to remove unwanted items. And if our filter is to remove unwanted contaminants and unwanted items, then the reality is that that filter was doing better. The more a filter does its job, the better a job it does. You know, when a filter first goes in, that picture of the filter, actually this picture here on the right, that brand new filter, when it is first installed, when that filter is first installed over here, that filter is, a lot of people call these filters rot catchers. In other words, it's only catching the largest material first. And the more and more it gets clogged, the smaller and smaller the space is that the filter has the ability to trap particles. Meaning the longer a filter is in place, the better it does at its job. As a matter of fact, smaller and smaller materials get trapped over time into our filter to where eventually the filter works so well that it filters out air. What I'm getting at here is the picture of this coil that you see right here on the left. That's actually the coil from my air conditioning system. And that's the coil from my air conditioning system after 2 years, 24 months of replacing that filter at the beginning of every month. In other words, I was using filters, the proper filter that the manufacturer required in my system. And I replaced my filter every month. Now, the way I did it at my house to remember to do that was every time I got my power bill, I knew it was time, and that was what I used as a reminder to replace my filter. Now, the dust, the dirt, the stuff that you see on that coil right there, that's just everyday life. And what I'm getting at here is the fact that even when we replace our filter, we're not completely doing the job to ensure that we're dealing with efficiency. Now, for that matter, how frequently should an air conditioning filter be replaced? I mean, how often do we do it on our properties? In various classes that I teach across the country, whenever I ask that question, we have a variety of answers that come up. Unfortunately, some of my students in the CAM-T classes that I teach come back that their community is not changing their filters on any regular basis. Now, I think that's a problem, because the true answer to this question, how frequently should an air conditioning filter be replaced, is actually that filter should be replaced every time it needs to be. Every time it needs to be. I mean, that could be once a month, as what I'm doing in my own system at my house, or it could be for that resident that has 3 dogs, 2 cats, a ferret, possibly a bunny or 2, maybe a bird, 4 kids, and they never vacuum the apartment. That could mean that that filter should be replaced once a week. What I'm getting at here is the way that a filter is designed. Even if we replace a clean filter, when we have a new filter in, airflow can still be an issue, because that brand new filter, especially if we're using that spun fiberglass filter that you can hold up and see through, if we're using that filter, then items, material, hair, dust, things are getting through that filter to the coil and to the blower behind. The reason we're going over this is I'm trying to motivate maintenance technicians, and we really need to be motivated to remember that efficiency is an issue even when we're changing out our filters regularly, which filters manufacturer recommendation means states for our industry that filters should be replaced a minimum of once every 3 months. In other words, replace the filters on your community once a quarter. The nice thing about that is by having that frequency as a baseline, we can start to schedule that throughout the year and make that happen in a preventative manner. Now, once we have new filters in place and once we're set, performing an efficiency check on the airflow is actually a fairly quick operation. All a technician has to have is 3 individual tools. You have to have a thermometer, which my preference is a digital thermometer, but even the old style neat thermometers that we used to get for free from our suppliers works very well. You need to have an airflow chart, and airflow charts are available. The one that I use in my own technician, my own practice, is put out by a company called Super Cool Slide Rule, and it's for free on the internet. All you have to do is Google them, and you'll find the chart that I'm about to show you here momentarily. The third tool that you have to have is a humidity tester. That can be in the form of a psychrometer, which I'm showing you a digital one there. You can perform this same thing with a sling psychrometer, which is an analog method or meter that is available, or you can get a hygrothermometer through various suppliers and needs. Generally speaking, you can get them for as inexpensive as around $30 to upwards of $200, depending on how much money you want to spend. But with these 3 tools, all a maintenance technician does is perform this efficiency check. Now, be sure that you're aware infrared thermometers do not measure air temperature. I know a lot of technicians like to use this tool, and it's really, really cool and very impressive in front of residents when we shoot it at air vents and we say, or we talk to residents about the fact that this is how efficient your air conditioner is doing. But for this test, we're not measuring the temperature of the vent, which is all that measures. Instead, we're looking to measure air temperature. So we need to have and make sure we're using a thermometer. Now, all a technician does, just to be more efficient or to be more exact about making a measurement, is to use this chart or a chart that's like this, available from various locations. And you need to have both a wet bulb and your dry bulb temperature. Your indoor dry bulb, which that is what you get off of your thermometer, and your indoor wet bulb temperature. And you take the wet bulb temperature away from the registers. In other words, you're not looking to make the wet bulb measurement in the direct line of the airflow coming from a vent. And all you do is you take your wet bulb measurement, which here we're going to say it's at 72 degrees, and your dry bulb measurement, which is 80 degrees. And all you do is follow the numbers across on the chart. By following those numbers across on the chart, what we see is that in this case, in this apartment, our supply air temperature, meaning the temperature of the air as it comes directly out of the vent, should be 67 degrees. Now, what this chart is showing us is that that air temperature as it comes into the room should be within 3 degrees, over or under, meaning that as long as whatever comes out the vent, that direct temperature, is between 64 degrees and 70 degrees, then our air conditioning system is operating at peak efficiency. We have that operating system running correctly. Now, if the temperature of the air coming out of the vent is too high, meaning in the case of the example that I'm presenting here, the temperature of the air coming out the vent is above 70 degrees, then we need to check the refrigerant charge. We need to look for a restriction in the refrigerant, or the ductwork in the attic or in between the space in between the apartments could be leaking. If, however, the vent temperature is too low, in other words, if the air coming out of the vent is below 64 degrees, then the filter could be dirty, the coil could be dirty, the fan blade could be dirty, the vents are closed or are obstructed, even possibly the rooms, the bedrooms, are sealed. You know, in order for conditioned air to get into a space, that means the unconditioned air needs to be able to leave the space. And if we have bedroom doors or room doors are closed, that restricts airflow throughout our system as a whole. That may even mean that our system itself could be operating correctly. However, a door that's been replaced or installed on a bedroom needs to be undercut higher to allow air to be able to leave the room even when the doors are closed. It's items like this that when we begin to think about efficiency, we have to have in mind. Now, the situation we just presented was a system that was operating, that was running. What if we're dealing with a system that is completely broken? I do want to take this opportunity and remind you, if I've raised any issues or you have any questions, please feel free to type any questions into the chat box. And at the end, Holly and I will answer or respond to those questions for more details. Next, we're going to look at what to do if our entire system fails, air conditioning system itself. And we're looking here at a split system. because there we have the most classifiable replies or the most classifiable problems or issues. You see, if we have a total system failure, right now in the marketplace, we basically have two decisions or two options to make. We can either just replace the compressor, or we may need to replace the entire outdoor unit, the entire condensing system. The benefit of replacing the compressor is that, generally speaking, it's at a lower cost, just part cost itself. It does tend to be a little bit more labor intensive because you're retrofitting older equipment to use a new compressor in place. And by the way, this option does provide little options for inefficiency change. In other words, if you take out a compressor in an older operating system and you put in a brand new compressor in that system, generally speaking, your SEER rating or your efficiency rating will end up being the exact same as it was before the compressor was replaced. Now, the new system, we can replace the full unit. Generally speaking, it's at a higher cost. Not only is it at a higher cost just because of the way that the system is in place, but it's a higher cost for the refrigerant that goes in, because you may need to perform major overhaul depending on where you're at in the country. Not only that, be aware that as of June of last year, the minimum standards that can be installed from an efficiency standpoint is based on where you're located in the country. Across the north, the minimum efficiency air conditioner that can be installed legally is a 13 SEER system. Across the south, the minimum that can be installed is a 14 SEER system. Oh, and just because you put in a brand new 14 SEER outdoor unit does not mean your system meets any efficiency standards. There are places right now in the country, and more places, it's my understanding, are beginning to require certification of the entire system. And the way you get to certify the efficiency of your system is by going to the AHRI directory for a certificate. What you see on your screen now is a certificate that I pulled up based on a mixed SEER system. Installing a 17 SEER Guardian condensing unit with a 14 SEER Aspen unit comes out with a certified rating of 15.5 SEER. Now, that's just happens to be in the middle of 14 and 17, but it's not guaranteed that that's how it's going to operate. I was speaking yesterday with a maintenance director for a management company that he's having a real issue down in Florida, where some of his communities are, that maintenance staffs put in a new outdoor unit and the city is not allowing it to operate because their indoor unit is 10 SEER or below, and you cannot get a certificate rating showing a high enough efficiency. Now, that's being enforced at the local level. But the end result is we have to be aware that when we put in new systems, they have to be installed with efficiency in mind. That's one of the considerations that we have. But you know, beyond what product we order, how it's installed speaks volumes about how efficient this operation is going to do. As a matter of fact, in this picture, what's wrong with the installation? What do you identify as being wrong with this picture? Now, most people, when I ask the question, what's wrong with this picture, they begin by identifying this. The fact that that unit on the right is sitting off of its pad. Well, that is very evident and could be a problem. Really, the biggest issue with this picture are the two units on the left. The fact that when a brand new condensing unit is installed, From manufacturer standard, they require 1 foot per unit, meaning there should be 2 feet in between those 2 condensing units. The reason why is that air coming out the top of those condensing units is actually being pulled right back through the coil. And that air from the get-go pulled heat out the first time it went through. If it's going to try and go through again, it's not going to pull out any more heat, and that takes away the total amount of heat that is able to be removed from these 2 apartments. So it decreases drastically the overall efficiency. As a matter of fact, suddenly the fact that that unit over on the right is almost falling off that pad, that's a good thing from an efficiency standpoint, because that unit has proper airflow. Outside of our apartment, we've got to be aware of that airflow issue. You know, before charging or before verifying the correct amount of refrigerant in a system, airflow has to be verified. You know, if our landscaper is shoving stuff all the way around that coil, or as you can see the picture on the right-hand side, how much air can get through that coil when it's restricted? By the way, that unit on the right-hand side, that unit is sitting right next to the dryer vents for the apartment laundry room. So needless to say, that unit's going to have to be cleaned regularly. Matter of fact, this time of year, before we get into the high demand for heating or for cooling this summer, go around to every condensing unit on your property and just take a simple garden hose with a spray nozzle on the end and just use the pressure from a garden hose, not a pressure washer. Just the pressure from a garden hose can knock off a lot of that dust and remove it. For more aggressive cleaning, you can get a coil cleaner, or we can use a coil cleaner to make happen. But making sure that we have that airflow in the outside unit is the beginning of the basic step to ensuring that we have the ability to properly charge our air conditioning unit, to correctly use our air conditioning system. Now, the first question to you is, how are technicians on your community adding refrigerant, or even just the process of verifying that they have the correct amount of refrigerant in a system? Are they using or going through a lot of the ways that I was shown early on in my career? Are they using the beer can cold method, or charge it to a specific temperature, or the outdoor temperature plus 30, or 20-degree air rise, or 18-degree drop, or add it till it flashes, or add it, or any other method? You know, just real quick on the way I was shown, beer can cold has absolutely nothing to do with efficiency. I mean, even though Fluke tells us the proper temperature to serve a stout is 42.8 degrees, just adding refrigerant until you reach that temperature does nothing for efficiency. As a matter of fact, if technicians are charging air conditioning equipment, if they're adding refrigerant until the line set gets to be the temperature of beer, then they're overcharging the system. As a matter of fact, from a manufacturing standpoint, equipment manufacturers state that there are only 3 methods to be used to charge an air conditioning system. You either use superheat method, subcool method, or weighing the refrigerant in. Now, weighing the refrigerant in, that's the most accurate of all, because there you go by what the manufacturer says. You use this whenever you know the line set length, or you have a PTEC or a hermetic system, like a PTEC or a room unit, a window shaker. Those, it's simply you find out how many pounds or how many ounces goes into the system, and you add it to meet that demand. The superheat and subcool methods are a little bit more involved. Superheat is the method that we end up using for a fixed metering device, and subcool is the method that we used if we have a variable metering device. Now, superheat is the amount of heat that's absorbed by the refrigerant inside. That's a measurement of the amount of heat that the refrigerant gains by removing the heat from the indoor air. And the way that we determine the amount of superheat is you take the suction line temperature right at the service valve on the low side pipe outside of our apartment. Measure it exactly where it's shown. You want to be, from manufacturer standards, you want to be within 6 inches of that valve. Not only that, you need the saturation temperature, which is gathered from the temperature on the inner ring of our blue compound gauge when we're performing refrigerant repairs. And superheat is equivalent to the line temperature minus the saturation temperature. That's the amount of existing superheat that we have. Now, in order to determine how much we're supposed to have, you have to take into account your current conditions. In other words, for current conditions, if my outdoor temperature is 70 degrees and my return temperature is 70 degrees, based on this chart, what it will show me is that I should be having a superheat of 14 degrees. So this chart is available. You can get it both from the manufacturer, or this one's available for free just by going to Google and type in target superheat chart, and you can get this. Now, be aware, for the greatest amount of accuracy, use manufacturer recommendations, and be aware that often this manufacturer recommendations requires the use of an indoor wet bulb. Now, when we're dealing with, or when we go to make changes of our system, we start out by adjusting it based on what the results are. We take our existing superheat and compare that to the amount of superheat that the chart shows we demand. And if we need to increase superheat, you pull out some refrigerant. If we need to decrease superheat, you add refrigerant. I realize this is a little bit backwards from what we normally think of. To increase something, you add, or to decrease something else, you remove. But keep in mind that when we're dealing with superheat, you're talking about a difference. And in order to increase the difference, you take out refrigerant. That decreases the pressure inside, and it also increases the amount of space that refrigerant has to expand in our system. So it's a little bit backwards from the way we think. Now, keep in mind that superheat is the method we want to use when we are adjusting or looking at the charge on a system that has a fixed metering device. Now, if we're dealing with a system that has a variable metering device, such as a system with a metering device on it that is classified as either a TXV or TEV. Those are acronyms for a thermostatic expansion valve. And in the case of using a system that has those as a metering device, you have to use subcool method in order to determine the quantity of refrigerant that goes into that system. To determine the existing subcooling, again, all we need is the line set temperature and the saturation temperature. Now, in this case, we're dealing with the amount of heat that is given away outside our apartment. In other words, if a technician takes their hand and they put their hand down next to the coil for the outdoor air that's being pulled through the coil, and then you put your hand on top of the system, but where the air is being expelled out the top of the condensing unit, you'll notice that the air coming out the top is hotter or elevated in temperature when compared to the air that's going in. It's the same air, but what you're doing is the heat that is being given away from the refrigerant. In effect, you're giving a rough example of subcool, the amount of heat that is being given away. For exact measurement, you measure at the liquid line service valve and compare that from, or take away from, the saturation temperature on the high side gauge. This means that you're measuring that inner circle temperature, looking at that inner circle temperature when your gauge is attached to the liquid valve right there where you're, right next to where you're taking the measurement. And what you do is you take the saturation temperature of the refrigerant and subtract from it the line temperature right at that valve. And what that gives you is the amount of heat that we're giving away. Now, subcooling is a little bit more straightforward. In other words, to adjust based on what the manufacturer says you need to have subcooling for. To increase the amount of subcooling, you add refrigerant. To decrease the amount of subcooling, you remove refrigerant. In both of those instances, a certified technician needs to be performing these adjustments or even these measurements to the amount or quantity of refrigerant that goes in place. Now, subcool is more exact based on system design. So the manufacturer can state down to the degree of temperature based on the conditions that you're dealing with exactly how much subcooling needs to occur. So in the case of subcooling, you need to use what your manufacturer states as the goal for your situation. Now, a couple of final things about charging, notes about charging. First of all, do not ever mix refrigerants. This is not only in place for an efficiency standard, but it's also in place as a legal standard. You see, right now in our industry, we're getting rid of R22. That change away has been happening for the past 20 years. And we're replacing R22, due to its price going through the roof, with other retrofit refrigerants that are being used in systems that were originally designed to use R22. Now these new refrigerants are being put in, and in some cases they're being sold as drop-in refrigerants. Be aware, drop-in refrigerant does not mean that we are to top off R22 in an existing system. To use that refrigerant properly, you have to remove all of the existing refrigerant and then put your brand new refrigerant in place. Keep in mind that any time you evacuate a system down to the atmosphere, you should be vacuuming that system properly down to as far as the manufacturer states. In many cases, the manufacturer's recommendation is to vacuum it down to at least 500 microns. That's in excess of 29.8 inches of mercury. Now, make sure that you're recovering refrigerant by your manufacturer instructions and follow all EPA regulations, which means that in order to purchase and use refrigerants, you must be certified. You can get certified through a lot of suppliers, and trade schools and tech schools will offer it, that certification test, for a fee. Make sure that you're recycling refrigerant whenever possible. In other words, if you're recovering R22, the expensive refrigerant, from your system correctly, using filter dryers, both in the system, and use inline filter dryers when you pull the R22 out of the system. If you do that, then there's no reason why you cannot reuse that clean refrigerant into a brand new, or pardon me, into an existing system on your community or on your property. Now, we've gone through a huge amount of information, and I know that we've gone through it in a very, very quick time to keep the time of this class down to about an hour. For more information, you can find links to articles or information going on at the National Apartment Association webpage shown below, naahq.org/ROE. And in addition to that, next Wednesday at 2 o'clock, there's going to be another webinar for financial success with energy benchmarking. Now, if you would like to ask any questions, feel free to type them in now based on what we covered today. And I will take those questions and be able to answer them. For references to what we covered or what I used today, the material I spoke about or taught today is also found in the CAMT program, the Certificate for Apartment Maintenance Technician program, which information can be found again at the National Apartment Association webpage. In addition, the chart to use for air efficiency, to check air efficiency, can be found at supercoolsliderule.com. And the AHRI System Certification webpage can be found at ahridirectory.org. In addition, you can go to Google and type in any of those, that information, and generally speaking, find a link in order to get to that. Now, I would like to open this up to any questions that may have been typed in or been posed during the presentation, or anything that you've been typed in there now. So, Holly, has anybody asked anything?
I do not see any questions, Paul.
Then I'm going to take that to mean either the audience is extremely brilliant and already knows everything, and this was just a very good review, or I am that good of a facilitator that I've already foreseen all of their possible questions and have answered them within the content that we've covered.
Okay, then we'll end the recording.
Thank you all for attending, and I hope you found it worthwhile. If there are questions you would like to follow up with off air or after the presentation, you can either get in touch through the ROE webpage or directly through my email address, which is below. Thank you all. I appreciate it.